Welcome back. So one of the very first things you'll do when you're learning how to program in any language is often that you'll write like some procedural code. So writing a function that takes some arguments and then wraps up a bit of code that's going to execute. And then as you learn a little bit more, you might learn about object-oriented programming. So procedural is like just writing a bunch of functions or method calls or setting variables. And then object-oriented is when you start working with classes, defining your own types and storing state, encapsulating state, and working with that state inside of classes. And so what I wanted to do today was go over a really common game that's used when learning how to code, and that's Hangman. So the first thing I wanted to do is walk through it together with you and talk about how we might implement Hangman procedurally with just functions and storing state and passing it around as local variables, and then we can do a little bit of refactoring and turn this into an object-oriented implementation. So I'm in replit.com today, and I will share this out. This is a public replit, so you can kind of go through and play with it yourself. But this is what the game of Hangman is if you're not familiar. The game of Hangman, if you're not familiar, there is a secret word that's chosen from some word list somewhere. We'll just assume in our example here that it's called fast. Usually you'll have some number of lives that you have. So oftentimes it's 7, and the goal of the game is to guess the correct word or guess the letters that are in the word before you run out of lives. So if we don't know that the word is fast, we might be presented with a bunch of underscores, and then if we guess the letter A, then A will be populated in the template that's printed out, and we get to see where A is in the word. If we guess T, we'll again see where T is. If we guess a letter that's not in the word, we will not see it, and we'll also, in this case, we'll lose one of the lives that exist for this round of Hangman. Usually it's a 2-player game where one person picks a word and the other person sort of guesses the word. And so the very first thing we need to figure out is how do we actually get user input from the terminal? So we're going to run some code that asks the user for a guess, in this case, the letter that they want to guess. And then we're going to use that as their guess given some word. And so in Ruby, there is a method that's built in called getS or gets. And what this does is we'll prompt the user for some input. So if we run this, we should get, okay. So I renamed this to Hangman, but apparently it needs to be main. So let's try this again. Bundle exec Ruby main. Okay, so right now it's hanging and it's waiting for us to do some input. So if we type like, this is our input, and then hit enter, that is the value that is returned. After we hit enter, the letters here, this space is space, our space input, and then the new line character that's at the very end where we hit enter, all of that is going to be passed as the return value from the gets method. So if we say that our guess is just equal to gets, and then we say like, puts guess, or like maybe we say like your guess was, and then we can use string interpolation to print out the guess. So if we run this again, it's going to hang because it's waiting for our guess. And then if we type in, this is like guess 1 or something, so then it says your guess was guess 1. Okay. So a couple of things we probably want to improve here. At the beginning, we should probably print out something that says like, please guess a letter, right? And then we can have our the colon, and we might even have like a space. If we do this, because we're using putS, it's going to add a new line after it. So now we see, please guess a letter, and then it's on a new line, right? So we can say G, and if we hit enter, it says your guess was G. Now, if we wanted this G to show up at the end of the please guess a letter input, we can, instead of using puts, we can use print. And then we have this space at the end, which will allow us to like receive that input. So let's run again. And it's going to say, please guess a letter. And now we can say G is our letter. And if we hit enter, it says your guess was G. So this is looking pretty good. And this allows us to just get some input. Now, what's interesting is that if instead of using puts, if we use P to get the inspected value of our guess here, this will show us like what the raw underlying value is. So if we again run this and we type in G and hit enter, we'll see that the return value is actually G and then the new line character after it. And this new line character represents like it's a special character that represents going to the next line. And so instead of just having get s, we need to also say .chomp. So .chomp is a method on string that will remove the white space that is at the end, like the trailing white space, basically. So now if we run this again and we see p guess, so p, there's like p, puts, and print. We're seeing all three of these in this example. Print is going to print out the value of the string as a string and is not going to add a new line. P is going to print out the inspected value, meaning like what does it actually look like in memory. So if we say G here, we get back a G. Okay, cool. So we see our guess. Let's just put back our guess here. So that was like one of the pieces that we needed to figure out was how to receive a guess. Now the next step that we need to do is probably figure out how to randomly select some word from a list of words. So maybe we can just like start off with a really simple list of words. So say our words is an array, and in the array we'll have dog, cat, and fast. Okay? And one of the methods of an array is .sample. So we can say words, if we were to, let's just comment this out and say, if we were to print or puts words.sample, this should give us a random word. So .sample is a method on array that says just pick a random element from the array. So if we run this the first time, we're going to see dog. If we run it again, we're going to see some other word, potentially cat. Okay, so this is going to be random again. So words.sample is going to give us a random word. It looks like it's kind of just iterating over the words, but it is giving us a random word. So now we get cat back. So words.sample can be our method for finding what our new secret word is. So we're going to store words in an array, and then we're going to sample and grab one of the random words from the array and store that into this local variable called secret word. Next, what we need to do is figure out how we're going to display the characters, or like these underscores, if no correct letters have been guessed. So when we first start the game, how do we show this sort of template or whatever? Maybe this is kind of like the board. So maybe let's call it board. And what we can do is we can start off the board with a bunch of underscores in an array. And the underscore, like the number of underscores that we need, is the same as the number of characters in whatever the secret word is. So in this case, we have two words that have 3 characters and one word that has 4 characters. So instead of just hard coding the underscores directly in an array here, what we need to do is figure out how to make an array that has the same number of underscores as the secret word. And so one way we can get the number of characters in a word is by looking at its size. So if we say secret, if we say puts secret word.size, that should give us the number of characters. And so this word was 3. Let's also just puts like what is the secret, like the secret word is. This will just be for debugging as we go, so we know what the secret word is that we selected. Okay. And so the secret word is fast, and the number of characters is 4. So what we need to do is create an array with 4 underscores. And there's a whole bunch of different ways to do this, but let's just say that our board, maybe let's just say that our board, and if you're following along and you want to pause and try to figure out how would you make an array with that many underscores, go ahead and pause the video, try that out a couple different ways, and then when you're ready, you can come on back. Okay, so welcome back. All right, so we have secret word.size, and one of the things that we could do is we could say dot times and then underscore, and I think this should give us a board with that many underscores. So then if we just puts board, we should see that many underscores. Array cannot be coerced to integer. So I think this might need to go over here. Times. Okay, so now we see the word is dog, and we're seeing 3 underscores in our list. Cool. But the way that it's printing out is a little bit weird because they're all on different lines, and that's what puts is going to do when you print out an array. It's going to like separate it out by new lines. And so one thing we can do is we can take our list of underscores and join them with a space. So that should give us, so join is a method on array that allows you to create a new string where each of the elements in the array are separated by whatever argument you pass into join. So in this case, we're passing in a space. And here we see the secret word is fast, and we also see the 4 underscore. So that's kind of our board. So let's say that that's what our board is going to start out as, is just this array of underscores, and the array is the length of the number of characters in the secret word. Okay, so the next step is that we need some sort of looping mechanism where we can say, like, try to get a guess, and then if the guess was correct, we're going to update our board. If the guess was incorrect, then we are going to decrease some number of lives and work our way through to the end. So let's work on the bit here where we receive just one guess, and we want to update the board if that guess was correct. So in this case, what we want to do is say something like, we need to like find, or like, if any of the letters in secret word match, then update board at the location of the matching letters to reveal the letter, or like the guessed word. Okay, so the first thing we want to do is say something like, if secret word dot includes the guess, then we want to reveal that guess. So we can say board, or then we need to go like loop over the characters in the secret word. And actually, we don't even need an if statement here. So we can say secret word dot characters. So if we just print out this secret word dot characters, or dot chars, right? This is going to give us an array. So this gives us back an array where each element in the array is a letter from the word. So if we print this out with P, that'll give us the inspected version. So that kind of shows us an array version. So now this gives us each of the characters in the word. So what we want to do is say, like, we're going to try to get a guess, and then we're going to loop over each of these characters and see if our guess matches any of the characters. And if it does, we want to go back to the board and update the board in those locations with the guessed character. So let's do this again. So now we're going to like re-enable our guessing mechanism, and we're going to say, for each of the characters, each with index, do the character and the index. Okay. Okay. So we're going to iterate over each of the characters, and that's going to give us, so we're passing now a block. This is a block. We're passing a block to each with index, and the block is expecting 2 arguments, the character at that position and the index at that position. And now what we want to do is say, like, if the character is equal to the guess, then we want to update board at the index to be equal to the character. All right, so what we're doing here is we're saying, like, if the character at that position, so if D is equal to the guess, so if D was what we collected from the user input, then the index at D, so the index would be 0. So we want to update the board at index 0. So remember that board is an array of these underscores. We want to update the board at index 0 and set its value equal to the letter that is at that position. Okay, and then if that all worked out well, then we should be able to print out the board and see if there was any updates made. So if we run this again, and we see that the secret word is dog, and it says, please guess a letter. So if we say D and hit enter, your guess was D, and now our board representation, our internal representation of the board, is updated to have D. So now we need to like guess what the other 2 letters are, but the terminal has returned here because we have no way at this point to go back and get another guess. Okay, so at this point we have a couple of pieces in place. We have the guessing piece in place. we have the logic to update the internal representation of the board when a letter is guessed. But now what we need to do is have some logic to like start that process over again. So what we might do is say while true, and then we'll wrap this entire thing in a while loop, okay? So we're gonna just move all of this over, and we're gonna say while this is true, we're just going to print out please guess a letter. We're gonna get the letter, and then after we have received the letter, we'll print out the board. And in this case, we wanna print out the board with .join, and we'll give it that space again so that it looks somewhat nicer. Okay, so if we say, if the word is dog, let's guess O and hit enter. Okay, it says your guess was O. That looks great. And now we see, underscore O underscore. If we guess now G, it says your guess was G, and we see OG. If we guess D, now we see dog, and that is the actual word. So that's all working fantastic. But it turns out that we can just keep guessing, and it doesn't do anything. So we have a couple of things that we need to do, and that is we need to update our while loop so that it only loops, or it only continues receiving guesses if we have both lives remaining and if we have not completed the word, right? So instead of saying while true, I think what we want to do is say while lives are greater than 0 and while board dot include, maybe if the board doesn't include any underscores, so if the board does not include any underscores, then, or while the board does include underscores. So we only want to loop if the board still includes underscores. Otherwise, and then at the end here we can say like puts the word was, and then the secret word down here. Okay. And then this concept of lives, we don't actually have any concept of lives yet. So let's create a new local variable called lives. So we can say our lives are 7, and then if the guess was not in the secret word at all, then we can decrease lives. So at the bottom here, maybe we can say like if secret, let's say, yeah. So we want to say like if secret word dot includes the guess, then we will update the board. Otherwise, we will decrease lives, minus equals 1, and we can just print out like the word did not include guess. Okay, so if we stop this and we run it yet again, okay, and we see undefined method includes, is it include? Okay, please guess a letter, so D. Okay, again, include is not the word, include. Okay. That one always trips me up, include versus includes. Okay, so F, A, Z, J, K. Okay, I'm just going to guess incorrect letters for now. Okay, so eventually we did fail, but we don't actually have any feedback about the number of lives. So let's say you have lives left. Please guess a letter so that we can see how many lives we have left. And if we say like X, Y, Z, okay, so like you have 5 lives left, you have 4 lives left, J, K, L, M. Okay, so then you had 1 life left, and then you failed, and then it says the word was dog. All right, so that logic is sort of working fine. The one other thing that we want to do here is check to make sure that it will finish if we correctly populate the word. Okay, so F-A-S-T, and it says the word was fast. And that's it. We kind of have like a working version of Hangman at this point. Now, one thing that you'll notice is that it's actually like not that long. So there's about 43 lines here, but it is pretty tricky to figure out how all these pieces work. In order to like debug this and work through this, if we wanted to add more words, or if we wanted to like change the logic for how the words were sampled, we would have to do that all in this sort of like procedural way, right? And so at this point, what I think makes most sense is to refactor this entire game into some classes, and maybe just one class to start with. But let's talk about how we might do that. So now we have kind of like all the pieces figured out. We've written all the different pieces, but now what we want to do is make it so that it works as a class. So we can define a class by saying, and actually I think I might just comment out this whole bit down here and say this is like our like procedural our procedural implementation. Now let's say like let's do our object-oriented version. Okay, so we're gonna say now we have an object-oriented version. Okay, so if we have when we're working with object-oriented programming, we generally are going to create classes, and those classes represent actors in the system that are gonna like send messages to each other. In this case, we probably just want at least one that is for the game, the class for the game. So we're gonna say class hangman. We could probably call it game also if we wanted. And inside of hangman, we'll probably want some different methods. So one of them might be like to do some setup, right? And the setup is gonna be like initializing the number of lives and initializing the board and like finding a secret word and things like that. So when we're setting up an instance of a class, there's a special method that we can call, and that is called initialize. So here we can say def initialize. And initialize can optionally take arguments. It doesn't have to. But here what we might do is say like at lives is equal to 7. Okay. And the other thing that we might want to do is say like at board is equal to, and then we can sort of take our same logic that we used up here to initialize the board, which is going to be, you know, like some secret word time dot size times the number of underscores. And so we're doing similar setup that we did before, but there's going to be a couple of differences. So another thing that we might do is call a method here like setup board, and that method would actually do this bit for us, and it would know about only know about its one job, and that one job is to like configure the board. In fact, we might actually have a separate class that is purely for maintaining and managing the board. In this case, in this game in particular, the board class, or like the concept of a board is pretty simple. It's just an array with underscores, right? And so, but if we wanted to make this something different, if we wanted to make it stars or whatever, then we could theoretically have some class that's completely responsible for maintaining what a board looks like, how a board is rendered, and a number of different things. All right. At this point, we have a game. We have some concept of a secret word. For now, I'm just going to put in fast. I'm going to hard code fast and show how we might initialize this game. So down here below the class, I'm going to create a new variable called game, and I'm going to call it hangman, hangman.new. And then I'm going to say game.start. So this start method is going to be when we actually play the game. So let's probably have some def start method here that's going to say like puts like welcome to hangman, right? Okay, so let's run this and we'll see. So we should initialize a new instance of the game, and then we're going to call start on the game, and that's going to say welcome to hangman. Now within our start method, this is where we probably want to do our looping, and our loop is going to again do these simple things, which is like print the board state, like receive a guess, and then like update the board. And again, our loop is probably all going to be based on whether or not this game is over. So like while the game is, while the player has lives and has not won. Print the board state, receive a guess, update the board. Okay, so it's going to be very similar to the loop that we had above. Again, right here, while lives is greater than 0 and the board doesn't include this, but we can make that a little bit more easy to read and a little bit more organized because we have these classes, and we can write methods that are going to make it a bit easier for us to maintain. So we have this setup board, we have our lives that are being set up. We're using the @ sign in front of this word lives and in front of the word board because we want to maintain that state as part of each instance of the game. So it turns out that like you could actually have multiple different games going at once as long as you're calling hangman.new to create several different games. So right now we're just storing the number of lives in an instance variable and the board in an instance variable. We're setting up the board. Let's make our method print the board state. So let's say board state, and this is going to be returning the board dot join, and we'll just return the string value for the board state. So rather than actually printing the board state here, we're just going to return it as a string and then expect that whichever method is calling that knows that it should be printing that out. So now we can just say like, puts board state. That'll print out the board state. And then, yeah, why don't we run the game now? So it should say welcome to Hangman. It should print out the board state. Okay. Let's also say receive a guess. So we'll say guess is equal to make guess. Okay, now we need to write a method make guess. And this is where we're going to put our logic to say gets. Okay, so this is going to be our logic for gets, or for receiving the guess. Okay, so you have blank lives left, so please guess a letter. So in this case, we probably only want to print out please guess a letter because that's really all that's part of making a guess. Printing out the lives isn't really part of that step. And so what we can do is we can actually just return gets.chomp from this method. So that'll be our last, that is the last line of this function. Because it's the last line, it is returned implicitly. And so that will store the resulting guess. So this return value from make guess is whatever user input with the new lines removed, and that'll be stored in this local variable guess. And then we want to update our board state. So we might make a method here that's called like update board with our guess. So we're passing now the guess as an argument to update board. And now we need to make another method down here called update board that's going to receive the guess, and it might update the board. So if the guess was in the secret word, which at this point we don't actually have a secret word yet. So let's make a secret word here. So def secret word. And for now we can just return the string fast. And then we can update our hard-coded fast here with the secret word. Okay. And when we update the board, we want to say like if secret word.include guess, then we want to actually update the board. And again, this is going to be very similar, so we can use nearly the same exact logic. Let's actually do it a little bit of a different way so you can see a couple different options. So secret word.chars.each with index. This was one alternative for updating our board. We can also iterate over those characters using something even simpler, like maybe even just a while loop. So if we just say like I is equal to 0, and we say while I is less than secret word.size, I plus equals 1, and we want to say, okay, so let's check to see if the guess, if guess is equal to secret word at I, then we want to replace at board at that index with the guess, or with secret word at I. So the reason why I'm using the secret words actually in both cases here, so in this case, right, we said if we're going to iterate over the characters of the secret word and check to see if the character equals the guess, and if it does, then we're updating the board index with the character from that position. So we could have also done guess at that position. But the reason why I'm doing character at that position is that if we wanted to make this a little bit more robust, we could technically like munge this guess value to make it a lowercase value or uppercase or whatever. So if we know for sure that the character, and maybe if we want to like sort of normalize the two of them, we could say like dot down case and dot down case on both the character and the guess, and then always update with the character. That way the resulting secret word is revealed in the format that the word list provided it to us. So in this case, we could say something also like down case dot down case. This will make it so that if the guess was like A and the letter was like A or something, like if the character at that position was A, then this will result in like converting both of them to lowercase and then comparing. All right, so that should work if the secret word does include it. Otherwise, we want to decrease lives, so at lives minus equals 1, and that should work. Okay, so we now we just need to add in our while loop. So we can say while at lives are greater than 0, and let's just do at lives are greater than 0 for now, and that'll give us something to loop. Okay, so now if we run this, welcome to Hangman, please guess a letter. We don't actually know what it is, but we know it's fast. So if we do F, then we see F, and if we do Z, then nothing is there. A, B, C, D, E, F, G, H. Okay, so it did eventually, we did eventually run out of lives. So one other thing that we want to do is probably print print the number of lives. So let's just do puts like you have at lives left, and then, or actually, yeah, let's do some new lines before that, so that we can kind of separate each of the lines here as we go. The other piece that we want is, yeah, so you have 7 lives left. Please guess a letter. So the other thing that we want to do, I believe, is we need to improve this to see like if we have actually won. And so our concept of winning means that the board state matches the secret word state, basically. So here we can say when the lives is greater than 0 and it's not 1. And so by writing not 1, we can write a new method. And notice that this method allows us to write a question mark at the end. It is conventional to name the functions in your classes, or to name methods in Ruby that return Boolean values, to name them with a question mark. It's just one of the conventions. In other languages, you might see something like is1 or like is1 like that. In Ruby, it's nice because you can just put like one question mark at the end. And now we see like, so if the lives are greater than 0 and you haven't won, then we need to define what it means to be won. And one option that we have is we could check the board against, so in the previous implementation, right, we checked to see as long as the board didn't include any, or if the board included underscores, we know the game wasn't over. Now that's a little bit fragile, because if for some reason you have a word in your word list that actually has an underscore, then I don't know why that would happen, but it might. So what I think we want to do is we want to check that at board.join without any arguments, or with the empty string, we want to see if that equals our secret word. And that will mean that for sure we won, right? If the characters that have been revealed on the board state match the secret word, the game is over. And down here we can say like if won, we can put like you won, and then else puts like you lost. Okay. All right. So then if we stop this and we run it again, Now we have a bit more logic. So if we say FAST, then we won and we had all 7 lives left. Cool. And if we run this again and we run out of lives, let's see, X, Y, Z, J, K, L, M. You lost. Okay, so this is working totally as expected. There's a couple other pieces that we could add though. One of them is we could actually keep track of the guesses and print those out, so we could show like, here's all the guesses that you've made. There's a couple other pieces that we might want to refactor. So generally, when you're working with classes in Ruby, it's better to operate on bare words. And by bare words, I mean words like rather than working directly on the instance variables, generally it's a little bit better practice to work on like a bare word. Like here we have secret word. It doesn't have an @ sign in the front, so we would call it a bare word. And so one of the refactorings that I think makes the most sense to do immediately is to create a reader method for lives. So if we say adder reader lives, this will create a new local instance method that returns the value for @lives. Now what we can do is come down here, and everywhere that we referred to lives with the instance variable, we can remove the instance variable from it. Okay, except here. So down here, we do want to use either the @ sign or we need to use something because we're setting lives. If we just remove the @ sign here, then what this is going to do is create a new local variable and set it equal to -1, basically. Or I actually don't know if it'll fail or what, but we either need to put @lives or we need to say self.lives -=1. And in order to do self.lives -=1, we need a setter. And right now we just have a reader. So we could create another method here called a writer, adder writer, or adder assessor, which does both. For now, let's keep it as adder reader, and then we will just update the instance variable when the lives are lost. Okay, and then similarly, let's also update the same concept for the board. So here we might say like adder reader for board, and when we call setup board, instead of setting the instance variable inside of setup board, another thing we can do to improve this a little bit is keep the instance variable setting inside of the initialize method, and then make setup board just return a new board that is already like prepared. Okay. We need to come back and update our secret word so it actually generates from some sort of list, but this is looking much better already. Here we can do board.join equals secret word. Another thing that we might do is like make it so that the board state takes in some separator, but this is also totally fine. So we're going to remove @board from all of these. This one works, and we're able to set it because when we call the board reader, that's going to return reference to that array, and we can still use the square bracket setter method to update it. All right, so let's run it, make sure things are still working okay. So we can say FAST, and you won. That's all totally working well. All right, so the next thing that we want to do is somehow wrap up our secret word and generate that from a word list. So instead of just having secret word here, let's also make a method word list, and this is going to return the array of possible words. So we have dog, we have cat, and we have fast. And then instead of having this getter method for secret word, what we can do is create an instance variable here at secret word is equal to word list.sample. That's going to generate, so it'll call the word list method, and the return value of the word list method is this array. And because it's an array, it has the sample method. Sample is going to pick a random element from the array and store it into this instance variable for the secret word. Now, this secret word, we were just returning this, we were hard coding and returning this string before. Now what we can do is say @secret word, and that will return the instance variable there for the secret word. Now if we run this, we should get a different word potentially that's not fast. Oh, and so what's happening now is it's saying that setup board has an undefined method size for nil class. That's because in setup board, we're trying to access secret word, but setup board is being called before the secret word is actually set up. So we want to like change the order of those so that we first generate a secret word and then we set up the board. So if we say run again, we now have 7 lives left. It's 3 letters. Let's try D. Okay, O, G. All right, so that totally is all still working. And one thing I wanted to point out was that like the way that this secret word method is implemented, where it's just returning this instance variable, is exactly what these adder readers do. Okay, so this adder reader is a class method available on all classes in Ruby, and that is just like a syntactic sugar or like an easy shortcut way to write these methods. So instead of writing secret word like that, I'm going to come up here and again make an adder reader for secret word, and that will wrap up our instance variable here. So we can run this again. 7 lives left. C, D, O, G. Okay, we won. That's fantastic, and we're looking pretty good. All right. So another thing that we might want to do is make this a little bit clearer. So if lives are greater than 0 and you haven't won, then we keep looping. But we're doing an actual comparison here. So if lives are greater than 0, so one thing we might want to do is just make this lost. Okay, so if you haven't lost and you haven't won, and then we can make the lost method that lives are less than or equal to 0, just to keep it safe. And yeah, so this is looking pretty clean. So now if we say run, welcome to Hangman, you have 7 lives left, D, O, C, A, T. All right, you won. Okay. I am pretty happy with this. A couple of improvements that we could make. Number one, we could pass in a word list as an argument when we initialize Hangman. This would allow us to do something like change the language that Hangman is played in. So if we wanted to pass in a word list in Spanish, we could do that. Or if we wanted to change sort of the difficulty, so if we have someone who's in 1st grade who's learning 1st grade words, we could pass in a 1st grade word list. Whereas if we had someone that was in 5th grade, we could pass in a 5th grade word list. So that's one improvement that we could make here. We could also change the way that our word list is sampled, in like maybe the first time the person plays, we give them an easy word that's a lot longer, and then the more times they win, we give them shorter and shorter and shorter words. And then, yeah, so we could sort of like change the intensity and complexity of this, but I think I wanted to stop it right here because this is kind of comparable to the version that we did above. In a procedural way as an object-oriented option. So hopefully this was helpful to you. And if you enjoyed this episode, if you learned a little bit about Ruby, I would really appreciate a like. Yeah, as always, just trying to help folks get spun up on how to code. So if you have any questions, or if this generated any thoughts, or if you have any feedback, please leave a comment below or hit me up on Twitter at cjavdev. Would love to chat with you. Thanks so much for watching. We'll see you next time.